Hi, I'm Paul Battaglia, and this is section 9.7, probability. You know, I think when we arrive at section 9.7, we naturally assume, or students certainly assume, that they've kind of seen it all when it comes to probability. But in reality, they've barely scratched the surface. And I'm joined by Gabe and Brittany, and we're going to try and outline for you a nice little blueprint that you can try and take into your classroom and structure your lesson accordingly. I would say one thing maybe, if you are going to cover just basic probability, try and maybe spice it up a little bit. Try and use some non-traditional objects. Maybe get away from the traditional six-sided number die or the coin, right? We do have some die up here. For instance, this is a six-sided die, but it has letters on it instead. This is also six-sided with just some colors. And this one's interesting. This one's a four-sided die. So, like I said, if you are going to do basic probability with these kinds of objects, try and make it just a little bit different. Stretch the students. Brittany, why don't you start us off? Talk to us a little bit about, there are actually a lot of terms that students have to get to know. Where do we start?
So I like to start with mutually exclusive.
Okay.
And so when with a mutually exclusive, I like to use a deck of cards.
Okay.
And the first thing I like to say is, can I draw one card that has, let's say, a 9 and is also a face card?
Right, okay.
No,
So
I
pretty
had
easy
to
for
draw
them to
two,
see,
right?
right?
Yeah. So that event is mutually exclusive because you can't have a number 9 and a face card at the same time.
Right, good, okay.
But now, if we look back at the jack, we can have a jack and diamonds at the same time.
Right.
So now this is no longer mutually exclusive.
Perfect, okay.
And now, the next thing I like to talk about is the independent.
Okay.
So if I roll this red die here, the outcome of this will not affect the outcome of rolling this blue die.
Okay.
While dependent, let's say we have these 9 die here.
Okay.
And so if I were to just pick out one of them,
Okay.
then it would be, the probability would be, just pulling this out of 9.
Okay.
While now if I took this one away,
Okay.
we have a probability out of 8. So it's dependent on that first.
That first choice.
That
You know,
first
it's
choice.
interesting. I actually see my students, they'll understand that, okay, we took a die out, and now I
Yeah.
have only 8 left, but they'll actually sometimes keep that numerator the same. They may say, well, we still have 5
Yeah.
blue, when in reality, that's the one
Yeah.
that we took out.
Yeah, we only have 4.
So that's interesting. Gabe, where do we go from here in terms of the complexity of things? Because things do get a little bit different, or we can talk to students a little bit more.
Sure. So there's problems that we can present to students where we can calculate probabilities rather easily.
Okay.
And there's some where it might not be so easy to
Right.
calculate these probabilities. So we also like to introduce this idea of the complement
Okay.
of a probability. And just an example that I like to give my students is, let's say we're rolling 2 die
Okay.
with the dots on them.
Okay.
So we have some sort of numbers that we can go off of. And I ask my students, well, what's the probability that the sum of these 2 die is greater than, let's say, 3?
Okay.
So the students can sit down, they can actually calculate, well, what exactly the probability is.
Right.
It might take them a couple minutes, but they can do it. But now, if I really wanted to scale this problem up, I could say, what happens if we roll 6 die and I want to know what's the probability
Right,
that
right.
it's greater than 10?
Right, right.
Well, it would take
too
quite a
much,
while.
right,
right.
Yeah. So we introduce this idea of the complement of a probability by saying, well, rolling greater than a 3 and rolling less than or equal to a 3 are mutually exclusive events. So instead of going through and calculating these probability from the sum of 2 die being greater than 3, well, really we just need to look at 1 minus the probability that we roll less than or equal to a 3.
Beautiful. I hope these tips have been helpful for you, and you find much success in section 9.7.